Okay, today we're looking at Module 4, Lesson 26, one-step equations, addition and subtraction. Today, a whole bunch of different lessons are all going to come together to one and all make a whole lot of sense, okay? So before we move forward on today's lesson, I want to take a minute and flash back all the way back to Lesson 1 in Module 4. Do you remember back, this is an exact question from Lesson 1. We talked about finding the identity. So A plus B minus what gives us A? B. Right. If I'm adding something to it and taking that same something away, I have the identity. If I have C, take away D, and then I put D back, I still have C. E plus what minus F would give us E? Everybody? F. And then what minus H plus H equals G? G. So we were always able to get our identity back if we added and subtracted. We did the inverse, right? The inverse operation. That's going to come back into play today's lesson. Right now, let's take a look at the board. I have a tape diagram here, and this one is worth 8. Now, my equation is A plus 2 equals 8. So here I have something plus 2, and if you notice, it's the same size as the 8. They are equal. So what would that box be? A plus 2 equals 8. So what plus 2 equals 8? 6. So we know that this box would equal 6. So if A plus 2 equals 6 plus 2, what do we know about A and 6? They are equal. Exactly. So A equals 6. So A plus 2 equals 8. And we know that A equals 6. And we can see that in our tape diagram. It depends on what the directions tell you to do. Okay, today we're going to look at solving these with tape diagrams and algebraically. Sometimes I'll tell you which method to use. Sometimes you'll get to choose. Okay? So let's take a look at exactly what this means as far as how we find the value of that variable. So here we have B plus 9 equals 15. So the directions tell us to use both a tape diagram and algebraic methods for each problem, and it says to use substitution to check our answers. So there's 3 things that we need to do for this. So first of all, what's my total amount? What do I have? I have 15. So I'm going to draw my tape diagram to show 15. Now, equal to 15, the other side of my equal sign, I have something plus 9. What is that something? What plus 9 would equal 15? 6. So we have our equal sign in our equation, and we can see that these 2 tape diagrams are equal. So far, so good? Now let's take it to the next step. Here's my 15 again. And I know from my equation that B plus 9 would equal 15. I'm closing the windows. I'm afraid one of you is going to get kicked out the window and be riding away with the Wicked Witch of the West bicycle. All right, Toto? So now, back to what we did with the opening, we know that that is equal to that. So let's show that. So I know that 6 plus 9 is the same thing as B plus 9. All I did was take this tape diagram and this tape diagram and put them side by side. I know that they're both equal to 15. So if I look at this part, what do I see? to see that 6 is equal to B.
Do we have to do all those diagrams on the homework?
Well, when they ask for the tape diagrams, yes. Okay? So now we could see that B equals 6. Yes? Well, one is using the 6 because 6 and 9 equals 15. The second one is a B. I know, it's a silly example. They shouldn't have used the same. That's a B. That's a B. Alright, so that was with the tape diagram. Now let's solve it algebraically. I'm going to use a different color. So we have B plus 9 equals 15. I want to find out what the B is. I want the identity of the B. I want to be the B. What was that identity rule? If I'm adding 15, I'm sorry, if I'm adding 9 to it, what do I have to do now to find the identity of B? Adding 9, I just want the B, I don't want the 9 added, so what am I going to do? I'm going to subtract the 9. However, I have to be careful now. If I subtracted 9 on this side of the equation, remember in science how you use your triple beam balances and you got them to balance, both sides were equal? What happens if you took something off of one side? Dunk. Is it equal anymore? No. So you would have to take something off the other side so that they stay equal. So if I took 9 off of this side, I have to take 9 off of this side, kind of like what I did here. So now, this gives me my identity back on this side because plus 9 minus 9 gives me 0. Gave me my identity back as B. So what's 15 minus 9? 6. So again, I got the same answer. Twice I got B equals 6. 15 minus 9 is 6.
Yeah, she said you didn't have to do this.
Now I'm telling you, you do. I'm grading your paper. Okay? Now they want us to do a check. We talked yesterday and the day before and all week about making statements true. So if I replace B with 6 and get a true statement, then I know I have the right answer. So first up, I'm going to write the equation. B plus 9 equals 15. What does B equal? 6. So again, an old lesson coming forward, I'm going to replace my B with 6 and bring everything else down. 6 plus 9 is 15. Bring everything else down. Does 15 equal 15? Yes, that's a true statement. So when B equals 6, that's a true statement. Since it's a true statement, I know that's the right answer. B equals 6. Okay? Questions on any step here? Where'd you get a number from? Why'd you do it that way? Where'd that come from? Why'd you subtract? You sure? Okay.
A step like in the middle, for the second one, it says B plus 9 minus 9. Why'd you minus 9?
Because the identity property gives me my identity back. Remember, if I have A, okay, I have A. If I add B and then I take B away, I have my A again. So what I did was to get the identity, if I added it and I took it away, they kind of cancel each other out. So that leaves me with B, because I want to know what B is. I want to find the identity. So that identity property that we practiced way back in lesson 1 is now coming into play.
But doesn't 6 plus 9 minus 9 isn't equal 15?
Yes, it does. 6 plus 9 minus 9 equals 15. What's 6 plus 9?
15.
Oh. That's because you have to bring the minus 9 on this side. So this is 15 minus 9 equals 15 minus 9. 6 equals 6. Because remember, we have to keep both sides balanced. So if we're taking away 9 from this side, we have to take 9 away from that side. Let's try another one. 12 equals 8 plus C. So what is it that I have? We have 12. I'm going to draw my 12. And I know that 12 is equal to 8 plus what? Yep, but what number can I use? 8 and what would equal 12? First I want to see what 12 is. 4. Now I'm going to write it with the equation. So 12 is my whole. And I know that 8 plus C, because that's what I was told up here in the equation. So now I'm going to take those two bars and put them side by side. 8 plus 4, 8 plus C. And those are equal because I know 8 plus 4 equals 12, and I know 8 plus C equals 12. Yeah, I don't know why they do it this way. I personally would like to do the variable model first. Yeah, I would accept it either way. So now if I ignored those 8s, I could see that 4, whoops, that was a terrible box, equals C. So C equals 4. So that's my tape diagram. Let's try it algebraically. So we have 12 equals 8 plus C. To find the value of the C, I have to find the identity of the C. Well, I have C, but we added 8 to it. How do I get my C back? If we added 8, how can I get my C back? Everybody? Take away the 8. But if I take away the 8 from this side, what do I have to do? Take away the 8 from that side.
Wouldn't it be the other way? Like C plus 8 minus 8, and then you would do it.
Well, we just have it written that way. That's okay. We have the original, then we rewrote it. So whatever I do on one side, I do to the other side. So 12 minus 8 is 4. And that leaves me with C, because 8 minus 8 would be 0. Plus 8 minus 8 leaves me with the C. So again, C equals 4. I got the same answer. So now let's do our check. Write the equation. Replace the letter with the number. Does 12 equal 12? That's a true statement. So replacing C with 4 made that a true statement, so C does equal 4. Let's try with subtraction now. A lot of people are still making mistakes or being confused with how to draw their tape diagram for subtraction. What do I have? In D minus 5 equals 7. What is my total amount that I'm starting with? What do I have? D, very good. D, that is what I have. Then from my D, I'm taking away 7. Whoops, no I'm not. Sorry. What did I take away from D? 5. So what is this? That's D minus 5, which is 7. We know that it's 7. So if we know that's 7, what is my total? What is my total? 12. So D equals 12. Algebraically, we're going to solve it the same way as we did before. D minus 5 equals 7. To find the identity of D, if 5 is being taken away, how do I find the identity? What's the inverse? Add 5, right. So D minus 5 plus 5 equals 7 plus 5. I have to do it to both sides. So that leaves me with D on this side, and 7 plus 5 is 12. So again, I got 12 as my answer. We're still going to check it. D minus 5 equals 7. Replace the letter with the number. 12 minus 5 is 7. 7 does equal 7, so that's a true statement. So that works. So that means 5 is the solution for D. Questions on where any of those steps came from, or the pictures, or the numbers, why I added, why I subtracted? All right, I'm going to ask you to try A on your own, but I want you to do it with the tape diagram and algebraically and the check. I know it says that you could choose, but this time I'm going to ask you to do both as practice. Okay, let's try it. So first with the tape diagram, you know that the whole thing is 20. How many of you want to draw it algebra with the, oh jeez, oh, it's really blowing on my stuff. Okay, hold the recording. Okay, so back at it. So it's 8 plus 12 equals 20. We know from the equation that E plus 12 also equals 20. So we could bring down our 8 and our 12 and our E and our 12, and then we see that our 8 and our E are equal. So E equals 8.
I put my on the other side.
That's okay. That's okay. So now E plus 12 equals 20. I want the identity of E. So if I'm adding 12, I take 12 away to get back to my E. But if I take 12 away on that side, I have to take 12 away on this side. We want both sides to match. This leaves me with my identity on the left. 20 minus 12 is 8. So again, I got E equals 8. So now for the check. E plus 12 equals 20. Replace E with 8 plus 12 equals 20. 20 equals 20. So that's a true statement, so the solution works. Questions on that one? Your papers match the board? No problem. Let's try B. You should have tried that one on your own, so let's go over our answers. This one I wanted you to solve both ways again, so I could see if you were practicing both. Your homework, you don't have to do both. Follow the directions on your homework. It tells you which ones to do the tape diagrams and which ones to do algebraically. But all of them you should do the check. All right. Careful with the subtraction. What are we starting with? F. Then from my F, I'm taking away 10. So that means this side is F minus 10 equals 15. So it means if this is 10, that equals 15. So what's my total amount? What was my F? 20. So F equals 25. Now the picture's drawn. Algebraically, so F minus 10 plus 10 gives me my identity. But I also have to add the 10 on that side. So F equals 25. Did they have a question on that? You want to raise their hand where one of those numbers came from? Okay. So now for the check, F minus 10 equals 15. F is 25 minus 10 equals 15. 15 equals 15, so that's a check. That solution is true. Questions? No? Yeah, okay. Yeah, I'm sorry. Oops, hello. There we go. That was a 15. You're always going to take your original equation and write it for your check. C. For cookie. Putting my cookie. Are we ready to try this one? Or you need a minute to do it on your own. Do it any method you want. Go. Right, if you chose the tape diagram, let's take a look at how many of you chose the tape diagram method? How many of you chose the algebraic method? Interesting, it's like half and half. The last period was half and half too. Interesting. Okay, so I have a really terrible box that represents 9. So this one is, I thought that was addition. It's subtraction. So I have to draw my better box. That's G. So now I have G that has minus 8. So what's that? 9. So what is 8 plus 9? What's 8 plus 9? 17. So G equals 17. So algebraically, G minus 8 equals 9. G minus 8 plus 8 equals 9 plus 8. So G equals 17. So now for the check, write the original equation, replace the letter with the number, solve, and so since that's a true statement, it worked. It's a solution.
If you didn't take diagram or algebra expression, do you have to do check for both of them?
Yes. No matter which method you choose, you have to do the check. Okay, yes.
Wouldn't G also equal 1?
No, because 1 minus 8
Oh.
is negative 7. Okay? So real quick in closing, John checked his answer and found that it was incorrect. So John's was H plus 10 equals 25. To check it, he did H plus 10 plus 10 equals 25 plus 10. So H equals 35. What did he do wrong? Just tell me what he did wrong real quick. Right, it should have been minus 10. You have to have that inverse to find the identity.
On the homework, you have to explain in words of what he did wrong or
When it asks you to, yes. Okay, just follow along with what it asks you to do in the directions. All right? Good.